Okay guys, hi, this is your instructor on Sunday night of Unit 4. And I just thought I'd check in and talk a little bit about a few things. I'll try to keep this brief. I'm going to talk about data sets and data and what that is, just to make sure that we're clear on that. And then I'm going to go through some of the student lounge questions. So this is halfway through the semester, and as you can tell, this is a busy class. I think it's busier than some of the other online classes, although you'll have to be the judge of that. We have a lot to do, and it's hard to keep up. It's hard for me to keep up, so I'm trying to do my best here and stay with you. But we have come through a lot, and a lot more to do. As I told you, I think in my estimation, weeks 4, 5, and 6 are the most busy. So we have a couple of busy weeks coming up, and then I think it trails off a little bit in terms of work. So let me just talk to you very, very quickly about databases. Get my slide to go on. So what does a database look like? So I took a few of these slides from another class I used to teach and added a few things here just to show you. And so most quantitative data that we create is put into a database, and by convention each row of the database is a case. So that would be a respondent in a survey, a subject in an experiment, or for content analysis each row would be a headline, a movie, whatever it is that we're studying, and in each column in the database is a variable. And then we analyze this with statistical software packages. And you might be familiar with some of these. SPSS is a very commonly used package. If you can get some skills at using SPSS, and that doesn't require too much, that is something worth putting on your resume, along with things like Qualtrics or other software packages. PSPP is a free version of SPSS. SPSS can be quite expensive. Excel is a data analysis software. You can use that. It doesn't have a lot of statistical tools, but it has some. Stata and SAS or others, and some of you have probably used a few of these. So here's what a database looks like. Each row is a unit, a respondent in a survey. Each column is a variable. Now, typically, each question in a survey would be converted to a number, and you've all seen this in the data sets that you took a look at. So we might ask, are you registered on Facebook? And for this particular question, all yes answers would be converted to a 1, all no answers converted to a 0. When you look in these databases, by convention, 9s indicate missing variables. Sometimes it's a 99 or a 999. Sometimes it's just a period. You'll quickly figure that out. But often we don't use 9s when we are putting numbers to the values of our variables. And that's because a 9 means it's missing. So when I always do yes equals 1, no equals 0, so I can calculate the percentage quite easily. The average score, if it turned out to be a 0.45, that would mean 45% said yes, they are registered on Facebook, something like that. But you could, frankly, use any number you wanted. You could say yes is equal to 5 and no is equal to 3. That just confuses things, but you can do it. Okay, so if you have a variable like this, which says, which of the following social networks do you belong to? Check all that apply. You're creating 4 variables, 1 for each possible response. And each would typically, for me, would be coded 1 or 0. A 1 meaning yes, they checked it. A 0 meaning no, they did not. So here are some questions. And there's how the variables might be coded. You can see one variable would be the first one, are you registered? And then we'd have 4 other variables, variable 2, 3, 4, and 5, for each of those possible boxes that they could have checked. So one of the things you realize quickly is that if you have a big question that says, rank each of these 10 items on a scale or something like that, you start immediately creating a lot of variables. And as you work with data sets, you begin to use that logic in thinking about your questions. You want to ask questions in such a way that they generate data that you can use. So here's our data set. Here is some data in it. Nothing too fancy there. Here's a larger data set. This one consists of 19 respondents. You can see 19 rows and 10 variables. You can see 10 columns across the top. So each row is a subject. Each column is a variable. And as I said, 19 subjects are n equals 19, 10 variables. You can see most of the variables have values of 0 or 1, but there are two variables, variable 8 and 9, that have values that run from 1 to 6. So there were more response categories for these particular questions. There's really nothing very complicated about this. We usually then are grouping variables in particular ways and looking across comparisons. This is data analysis. So this is another way to look at how we analyze data. We might compare the men here in blue to the women in red. So here we're using gender as our independent variable, looking across any of these variables of interest. Or we'll look at those people on Facebook in green to those people who are not on Facebook in purple. Again, our independent variable is whether or not they are on Facebook, and our dependent variable is whatever question we want to answer. So one of the questions I got from people was that they're having trouble finding data sets. They're not sure what they're finding data sets. And this is an interesting question. It really hasn't come up before, but this would not be the frequencies. This would not be a list of the responses. This is data. It looks like an Excel table. It looks like X's and O's. So try to do that and see how you do with that particular question on your summary assignment. Okay, I had a lot of great questions on the Student Lounge. I had asked for these questions as part of our summary assignment, try to generate some questions from you, and a lot of really good ones. I'm going to deal with 4 or 5 here very quickly. So one person asked, they said, what is the confederate referred to in the manipulation check section of the chapter? I didn't go back to the chapter here because I know what a confederate is, and I hope I'm using it correctly. And that is, a confederate is somebody who's working with the experimenter. The subject probably does not know that. So the subject, let's say, enters a room, and I'm the experimenter. I say, hello, I'm Professor Graf, I'm running this experiment, and you're going to run this experiment along with this other person. And it might be that that other person is working with me. They're an actor working with me. That's what we mean by a confederate, working with the laboratory or working with the person running the experiment. And often we don't tell the person taking the experiment, the subject of the experiment, that the confederate is working with us until later. Okay, I did want to make a point about field experiments. I talked about this briefly in the online discussion. And then somebody had asked a question or had posted a comment about field experiments. And they really sort of got the right idea here, but I want to emphasize it again. We had a chance to see a field experiment, and this one was done in a coffee shop. This is actually a study. I can send you the study if you like. It's pretty interesting. And it was people went into a coffee shop and they had their computers open and they timed how long it took people to get drinks. And some of the independent variables they looked at was gender. Do women or men take longer to get the drinks? And an important one was race. Are white people served faster or slower than black people? And they also looked at any other race that came in to order drinks. Okay, so a couple people, in talking about this, made a really good point. They said, look, this is messy. There are variables all over the place here. What about whether the coffee shop is loud and maybe they couldn't hear the order, or they made the order incorrectly and the person had to go back? What if it's a friendly barista who likes to talk to people as they make the drink? What if some people order drinks that take longer to prepare? There are lots of variables here. You're absolutely right. And there are ways we can try to control for these variables in a more complex field experiment. And in fact, the study I have does that. Okay. So why do this? Why do a field experiment when we could instead do it into a laboratory and we can control everything? Well, the problem is that we don't drink coffee in laboratories. We drink coffee in coffee houses. And latent racism or latent sexism takes place in the real world. So if I set up a coffee shop in my lab at the university and I invite people to come in and act as baristas, because we're really looking at the reaction of the barista, the person making coffee, you know, am I going to get the effect? No, it doesn't happen in a lab. It happens in the real world. So what we gain in a field experiment is external validity, and that is powerful and it's important. And there are lots of really good experiments done about topics such as this out in the real world, testing how people react to other people, etc. What you give up when you do the field experiment is control. And in the lab, I can control everything but that one independent variable, and consequently I become more and more confident that I can determine what causes what. I can get more close to causation in experiments, especially in a lab. Field experiments are not as good in that regard, but they have this wonderful external validity. So it's a great method, and there have been lots of neat field experiments that have been done, and that's the trade-off that we make between the two. Okay, a couple other interesting questions. Somebody asked, do researchers account for people lying when they conduct a survey? Well, we ask good questions to try to get away from that. And it is not assumed when calculating margin of error. Margin of error only relies on the sample size. So this is people lying on a survey is indeed a source of error, but it's not related to margin of error. So do not confuse those. What do we do about this? Well, we ask good questions. We don't try to trick people into doing our survey. We enlist their help. And most people, 99%, willingly and will give us good data. They want to try and help us out. And I say to them, I work at a university. Here are my credentials. I say to them, I am funded by this particular foundation. I establish my credibility, just like I do in any other social situation. And then I say, will you please help me? This is worthwhile. It'll take just 15 minutes of their time. I don't lie about that, too. I take just 15 minutes of their time. And I work hard to write good questions that are engaging and interesting and that get good data. And we most often do. Now, one of the lessons in a class like this, in a program like this, is lots of sources for error. Sampling error, right? Or if I have too small a sample, then margin of error, that's a different sort of thing. But all sorts of error places. Question wording where error can come in. And that's all true. But we should not be so cynical about surveys. Surveys give us good data. The larger problem is not people lying. It's people giving us answers they think we want, or people trying to answer questions in ways that they think we expect, when in fact that's not really how they feel. If we ask somebody a question, they assume that they should be able to answer it. Otherwise, why would we be asking? So we ask them things like, what do you think of the president's policy toward North Korea? And they'll say, oh, I hate it, or I like it. When in fact they have no idea what his policy is, and they don't care. And so we have to ask better questions to let those people reasonably tell us, I really don't know much about that, or to say, I don't care about that particular topic. The term for that is called satisficing. People are trying to help us out, but in doing so, they're not really giving us their opinions about what's going on. Demand characteristics are questions that prompt a particular response. This is not lying on a survey, and so somebody offered a response on the boards, and the examples that they posted really are not people lying on a survey. Demand characteristics are, again, when people are giving us questions, for instance, in response to social desirability. Let me give you an example. We ask people, do you read to your children at night? Everybody says yes. Of course, you're supposed to read to your children at night. Well, we know some people clearly don't read to their children. You ask people, do you vote? They say, yes, I vote. It's because we're expected to vote. And we know that typically between 10 and 20% of the people who say they voted did not. So they're responding to what they think is expected of them, to what they think are socially desirable responses. That's the greater problem, not somebody just out and out lying on a survey. Likewise, someone else had posted a link to the issue of people lying in an experiment. This is really an ethical issue, and it's not related to survey research. But it's when we bring people into a lab, we often are lying to them, or we at least are not upfront at the beginning about what the experiment is about. We'll talk more about that when we talk about ethics, but that's almost always the case. It's not necessarily harmful. It is simply we bring them in and we say, here we're going to do a study on this when really we're studying this. And the reason is because if they knew what we're studying, they would react to it. And that's what we do not want. Excuse me. Somebody asked about paying people to be in an experiment and to be in a survey. We often do this. We give people incentives. Incentives work. They encourage people to take a survey, to spend more time with a survey, and we think to give us more careful responses. Sometimes we give them incentives at the beginning, sometimes at the end, sometimes we'll enter them in a contest, things like this. So lots of ways. I'm not really aware of research that suggests that incentives prompt bad data. So I think incentives are generally good. The exception is if you offer incentives that are too large. So if you offer somebody $100 to take a survey, whatever good reasons they have for not taking the survey are thrown out the window. They're going to take that survey, going to get that $100, and they might very well give you bad data. But instead, if you give them $5, it's enough that it rewards them, it convinces them that you're serious, that you're taking them seriously, it's a little benefit, and so actually smaller incentives are better than big ones. So I'll stop there with that question. Okay, another question. In the back of the course text, there's a random numbers table in Appendix C, and some people are confused by this. It's a table of random numbers. So if you need a random number, you can access the table. So let's say we have a list of 100 people and we want to sample 10 from that list. There are lots of ways we could do it, but one way we could do it is I could look at a table of random numbers, and maybe I'll just take the first 3 digits of the first 100 digits of the first 100 numbers, because I think the numbers are like 5-digit numbers. So that would give me 100 numbers between random numbers between 1 and 100, and I could use that to randomize. Now this is random enough for us. For other big projects, random numbers tables don't work. So I guess I understand the confusion, but really it's just that simple. It is honestly just that simple. It's a list of randomly generated numbers. It can be useful at times. Okay, and my question is, are there clear ethics in survey making? Absolutely. The American Association of Public Opinion Research has an ethical code. There are lots of ethical codes in organizations. You know, we go forward in this class with the argument, with the unstated belief that you want to get good data. That we're not asking questions to prompt particular responses. Those are loaded questions. We're trying to actually find out how people think. And there are tons of loaded questions out there, just tons of bad loaded questions, often asked by political advocates, political organizations, because they want to get data that they want. They want to claim most Americans think blank, and so they ask loaded questions. Let me restate something I said earlier. A loaded question for this class is any question that prompts a particular answer. We are not surprised when obviously loaded questions get the answers you would expect. We're not surprised by that. Any fool can do that. What surprises us is those questions which are loaded in ways we never expected. Often we find out later that this question was prompting people to go one way or the other, and we don't want that. So our ethics in survey making, we're trying to understand how the world works. We're trying we're taking the scientist sentiment to it. There are lots of ethics in survey making, and there are a lot of unethical survey researchers out there. But certainly, Gallup, Roper, the major foundations, these are highly ethical people trying their best to ask good questions. They sometimes fail. They sometimes ask poor questions. But they are trying their best to get at how things really are. All right, so when I'm taking a Pew Research American Trends panel surveys, and I don't know if this person is a member of the panel survey, but sounds like it. There are times when I have to stop myself from rushing through the questions if I find them difficult to answer or boring. Well, that's a fault of the questions. And boring surveys are a problem. We need to do ways to keep people engaged and keep them interested, and some people are very good at this, but that's a problem. You get bored, you start putting down incorrect answers or answers you think people want. And people definitely take into account how quickly somebody completes a survey. Let me give you an example. I've done surveys that we time. And we know that it should take between 10 and 20 minutes to take the survey. If somebody takes it in 2 minutes, we throw it out. Clearly, they did not read the questions. They just went through and clicked answers. So we throw it out. Likewise, if somebody took 2 hours, we know that something funny is going on, and we toss it out because we want to get good data. Okay, a lot to talk about there, a lot of chit-chat. I hope it was some help on a Sunday night. I'll get this posted, and I'll get all our materials ready for Unit 5. I hope you had a good week, and we're into the second half of the semester. Thanks a lot.